Right, this is a help video for 4.11 unit test part 2. I have made up a different graph for number 1. It's the red graph. The original graph in the assignment is the black graph. 1A is asking you to state the domain. So a quick reminder that domain from 7th, 8th Algebra 1 days are your x values. So I'm just going to underline this. It's our x values, and when we're finding our domain, we're always looking from left to right on our graph. And range are your y values. And when we're looking for y values on a graph, we're always looking from low to high or bottom to top. If you get confused about x's and y's being domain or range, always have remembered that you can follow alphabetical order. Domain comes before range in the alphabet. X comes before Y. So that's how I remember x's go with domain and range goes with Y. So on my red graph, I did get this from Desmos, and it does go to the end of the graphing window. And anytime it goes to the end of the graphing window, you can assume that there is an arrow there. So on your original graph for number 1, you can't assume there's an arrow there, and the same thing up here. So on my red graph, it goes to the end of the graphing window. We can assume that it goes on forever. So when we're looking at our domain, we're looking at how far this red graph goes to the left. So it goes forever to the left because of the arrow. I can't tell where it's going to stop on the x-axis. So this looks like -4. This looks like -6, and it's going to go -8, -10, and it's just going to head out to all the way to the left. And so we know that's -infinity. So we're going to use interval notation. We used interval notation back in the inequalities unit. And then when we go left, and then it's going to continue without stopping all the way to the right. And then on the right-hand side, it doesn't just go to 6 or 8 or 10 or 12. It's going to go forever and ever to the right. And we call that positive infinity. All right, sometimes graphs stop. So for instance, if there was a point here and you didn't have this part of the graph, then the domain would actually be -infinity to 4. But since the graph goes forever to the right and forever to the left, it's -infinity to positive infinity. On the range, we look at how low the graph goes because that's the y's go up and down. So this graph, this is 2. This is -2. So it kind of looks like it only goes to -2. But if you'll follow the path of the graph, it is slowly going down, slowly going down. So we can't tell exactly where it's going to stop because it's not going to stop. So this graph goes forever down. So it goes forever to -infinity. And it goes forever. It continues up slowly, slowly, slowly. This looks like it's got a y of 2, but it's just going to continue to get higher and higher, slowly and slowly. So it's going to go to positive infinity. Again, if this graph stopped here, then, it would go from -infinity to about, 1.75 on the y. So sometimes it does stop. So just again, for an example, if it stopped right here and it doesn't rise forever, then you would go over here and figure out what that y value would be. In behavior, we can get kind of technical here, but a graph has a left end. So you could say the left end, and your left end is usually going to rise or fall. So here's my left end of my graph. It's slowly falling. It is falling. It is slowly, but you can say left end falls. And then here's the right end of your graph. And the right end, it is rising slowly, but the right end does rise. So right end rises. I'm going to go ahead and attempt to do this red graph. It's not going to be very exciting for number 2A because it says x-intercepts. So this graph is only going to cross the x-axis here. And it does say write as ordered pairs. So my x-intercept only have 1. It's at 0, 0. If you notice, you have 3 x-intercepts for your graph for this TGA. So make sure you do the 3 ordered pairs for your x-intercepts. it asks for y-intercepts. Again, my graph is a little bit boring. So my graph only crosses the y-axis here. That is at 0, 0, because it does say write as an ordered pair. This graph only crosses the y-axis one time. Maximum. My graph doesn't have a maximum the way it looks. So I'm going to kind of draw another graph here for the maximum. Let me kind of make something else up. So let me make something up for 2C. Let me try to draw x-axis. Y'all excuse my drawing here. So a max is considered any type of mountaintop. And if it asks for a min, it would be any type of valley. So since it's asking for a max, my graph doesn't have a max. So I drew this one just to kind of show you. So here is a mountaintop, and it would be the highest point of that mountain that's being drawn in the graph. And then you would go down and you would figure out what the x value would be. So let's say it's at, I don't know, 1, 2, 3. So it says identify the maximum of the graph. So the maximum would be at, let's say this is 2. The maximum would be at the point 3, 2. So again, a max is any mountaintop. And if they asked you for a minimum, it would be any valley, any little dip in your graph. For the next problem, it says use the space provided to respond to the statement considering the given function f of x. So they're giving us a polynomial function. Number 3a is saying use the fundamental theorem of algebra to determine the number of complex roots. So we just want a number here. So I would just suggest that you look up if you're not sure and you don't remember what the fundamental theorem of algebra is. This is not working anything out. You're actually looking at your equation, and there's going to be something visual happening in your equation that's going to tell you the number of complex roots. So no work here. You just have to understand how the fundamental theorem of algebra works. 3b says use the rational root theorem to determine the possible rational roots. So my hint here is that you start with this little formula that says plus or minus, and then you take the factors of the last term, and you're going to divide them by the factors of the first term. And then you'll have to work this out, simplify any fractions, and then you'll make a list of all the key here possible rational roots. And then you're actually going to use this theorem, which is the formula that I've given you. Number 4 says find all the complex zeros of f of x, show your work, add more space as needed. So it's asking you to find all of the zeros. So that means you're finding all of the solutions. Okay, we also use the word roots, but you have to find all the solutions to this equation. Not going to really go into detail here. We've done several problems like this. Go back and look at your recordings from your Class Connect. If you need more help on this one, you can ask, but this one is just going back and looking at your equation and finding all the solutions. Okay, when it says complex, it means that some of those solutions could be imaginary. All right. It says reminder that function f of x equals x cubed. Here's another function. It's the same function. It says use the polynomial remainder theorem to evaluate. So this is f of x, f of 5. It could be f of x, but they're saying that x is 5, so there's a really good hint. It says use the polynomial remainder theorem. So that means you're using synthetic division here. And it does say show your work. 5b says use the polynomial remainder theorem to evaluate f of 2. So same problem, using polynomial remainder theorem. That means that you're using synthetic division to find the remainder. And then this time you're using -2, when in 5A you were using, excuse me, positive 5. All right. Hopefully this was helpful. If you still have questions,